Hello, today I will be going through inductors in DC. An inductor is a two-terminal passive electrical component that stores energy in a magnetic field when an electric current passes through it. It is typically made of coil of insulated wire. An inductor serves to store energy in a magnetic field, resist changes in current, and control the flow of current in a circuit. Now let's look at an example of an inductor in a DC circuit. In this circuit, we have one battery, one resistor, and one inductor all at 1 respective to their values. Looking at this circuit, we can see that the switch is open, meaning no current is flowing. Furthermore, we can also calculate the time constant to be 1 using the equation shown below. But what would happen if we were to close the switch? Current will try to flow into the inductor. As a result of this, the magnetic flux around the inductor starts to build up, and as that magnetic field is moving and building, it induces a current inside which pushes back against the current that is being pushed in. We can call this back EMF as it opposes the applied voltage, which is Lenz's law. This can be described as the induced voltage in a coil which opposes the voltage source that led to the establishment of the flux. At this stage, with the switch closed at t equals 0, the inductor blocks the current flow, so it will look like an open circuit. If we were to place a voltmeter across the inductor, it would read as full voltage or 1 volt, as there is no voltage drop because there is no current. Now, after time goes by, the magnetic field starts to slow down and decrease. As a result of this, current starts to flow through the inductor. The amount of current through the inductor at a given time constant can be described in the equation below, where at one time constant, the current will be 0.63 amps. Due to the inductor not producing as much back EMF, the voltage across the voltmeter starts to drop. After one time constant, it is going to drop down to 0.368 volts. This can be calculated using the equation below. And now, after 5 time constants, the voltage is going to get closer to 0, where it will now be at 0.0067 volts. On the other hand, the current is going to get closer to 1, where it will now be at 0.99 amps. At around this time period, the magnetic flux is going to be completely built and no longer moving. The magnetic flux only pushes back a voltage while it is building up. When it stops, it no longer pushes back, so current will now be able to flow freely through it. Now at t equals infinity, the inductor behaves like a short circuit and looks like what it is: just a piece of wire. Thank you for watching this video. I hope you learned valuable information on inductors in DC circuits.